Hello. Today we're going to take a look at our first analysis of a real bit of malware. We're going to create a bit of malware in our instance of Kali. And once we have that malware created, we're going to take a look at it inside of our malware analysis tool set called REMnux. Now, I'm aware at this point that we've already taken a look at the iCar virus in class, and while technically that is a virus, as we saw with the payload, when we were able to execute that virus inside of the DOSBox testbed that we set up for it, all it did was it said, this is the iCar virus, which is really no real payload. Same thing's going to be here in that the payload for this is pretty basic. It's going to be easy to discover. It's not going to be that hard to spot. And this is just an initial analysis. We're not going to use any of the hash research. We're not going to do any of the static analysis tools. It's just going to be pretty rudimentary analysis. We're looking for clues. And just like when we were doing pen testing and we were looking for clues, same thing here. Now, the first thing you need to do is ensure that you have both Kali and REMnux running in your virtual environment. We have imported REMnux together and it fires up no problem. If you no longer have Kali available to you, you can go to kali.org/getkali, and then you can scroll down to the virtual machine section. There's a link at the top where you can scroll down to the pre-built virtual machines. And what you want to do is you want to download the 64-bit version of Kali pre-built for VirtualBox. It will allow you to download an OVA file. And I'm sure you will recall from last semester in our ethical hacking and pen testing course, we used OVA images that we downloaded as target machines, and we simply imported them into VirtualBox. Same thing here. You import it, confirm the network settings are matching for what you want to do in your VirtualBox environment, fire it up. The username and the password are both Kali. Those are the default credentials that will get you into Kali for today's class. Now, I have gone and started PowerPoint so that I can take a look at my notes, because believe it or not, I don't actually have this command memorized. So, of course, I don't expect you to have it memorized either. But we are going to use in Kali, first things first, we're going to create a terminal. Don't need to be root for this, you can just be a regular user. Okay. And I've zoomed in my fonts so it's a little easier for you to see what I'm doing. And I have the lecture notes right here. My PowerPoint notes, which of course you have access to as well. The command we are going to use is from those notes, and of course I'm not going to try and retype them without typos. So I am going to highlight them in my notes, and then I am going to paste them right here. That's what it should look like, and in case you want to see it, this is what the command looks like. What this command does is it uses the tool MSF Venom. We have seen this tool before. We used this tool in our ethical hacking and pen testing course last semester to create a PHP payload to deploy to a site that we were able to do an upload to. If you recall, it was that site written in Turkish that relied on client-side or JavaScript-based validations to mitigate against attacks. Once we circumvented those JavaScript mitigations, we were able to upload a custom-made payload that we would then manage through MSF console. We used MSF Venom to make that payload. And at the time, I hope I told you that there are a lot of different payloads available to you in MSF Venom. Way more than I have time to go into today, but MSF Venom alongside of the MSF Framework through MSF Console are two very powerful tools for the red team adversary in information security. we are going to use this to create an adduser in Windows payload. All right. With that, we need to specify custom arguments with that payload. It needs a username and a password. The password is uppercase, lowercase, special characters, and numbers. And what this does is it mitigates against any password rules that might be in place in our target environment. This is just a little bit of a real-world example of what we might do in that case. And then the format is going to be an executable. And then we output that into this executable. And when we run this, what it should happen is it should generate an executable that, when executed in a Windows environment, should add a user to the system. The WMIC is equal to true. Basically, that helps it resolve some administrative requirements when the command is run, if possible. Now, it's not going to be perfect. That's fine. But this allows us to at least attempt. I don't know why it's doing that. This allows us to at least attempt to, when this executable gets run, to try and run it as administrator if possible, to add this user to the system with this password. And that's basically all that this virus is going to do. So, providing there are no typos, or in this case, copy-paste errors from the source, when I hit enter, it will take a while for that to run through. And one thing I forgot to do when running this is I should have made a separate directory for it. If I'm going to use Kali, specifically if I'm going to use msfvenom to make malware, I should probably have a separate directory in my Kali for the malware that I am going to create. For those of you who are part of the class before, you know that I already did that, so I'm going to do a little background cleanup and make that happen. Of course, I'll do it in front of you so that you know what's going on. Okay? But at the end of it, you should see something like this. The final size of the executable file is almost 74K. Perfect. When I do an ls-al, I see my malware adduser.exe is sitting right there. Now, the permissions are not set. We've seen in the past when we've created shells using GCC that they will automatically create them as executables. It's not necessary this time. I mean, think about it. This is not going to execute inside of a Debian or Ubuntu-based Linux, or any Linux, frankly. It is a Windows executable, so the permissions are completely irrelevant in this case. Now, I do have a directory called malware. I already have some stuff in it. So, just ignoring that, I'm going to move my malware underscore adduser to my malware directory. So now it's no longer there. And I do that just so I can more easily share it with my malware analysis toolset, specifically REMnux. So, it's a couple of extra steps there, but at the end of the day, I want you to understand the process. Okay? I don't know why I keep getting the uppercase B, but that's annoying as sin. The process is this. We are going to type in the msfvenom command inside of our malware directory. We are going to use the adduser payload. We're going to add the user malware adduser. We're going to use this password that should meet most Windows systems password requirements. WMIC is equal to true is some way of trying to get around administrative requirements. We kind of hope that the person who runs this virus can do administrative level things. The format is an executable, and then we're going to output that to the Windows executable named file. When we hit enter on that, again, it's going to take a little while.
Moments later,
you will see that we have an executable that has been created that is almost 74K in size. And we see it right there. Okay, now that we have it in place, we want to analyze it. We want to take it and get it over to our instance of REMnux. And as we've done in the past, what we've been able to do is going into Kali, if we want to share something with a target environment, or we want to pull something from a target environment, we have a lot of choices. One of the easiest is to create a Python-based temporary web server that just does directory shares using a Python module called Simple HTTP Server. So we're going to use Python 2, I think it is, dash, I need to be root to do this. So sudo, there it is, Python 2 -m, we're going to load the module, and the module we're going to load is the Simple HTTP Server. As we've seen in class, there is a Python 3 module as well. This is the one that came up in my history. I don't care which quick, simple web server you fire up as a Python module. I don't care which version of Python you use. The point is we're trying to share this file with this testbed. We do that, in this case, with this command here. Now, before we do that, we should understand our IP address so we can connect to it when we launch this command here. So I know my IP is going to be 192.168.56.191. I will start my web server. Of course, you're going to need to type in the command because you're using the sudo command. But now I have a web server in the malware directory running on this IP address here. I'm going to go to my target. Okay, sorry about that. I had a little bit of an issue with my mouse, but it seems to be resolved now. So I have Kali working. I'm now going to launch a browser inside of REMnux. Okay. The address I am going to use is the address that I saw over in my instance of Kali, which I'm mistaken, if I'm not mistaken, was 193. Yeah, or 191, that's what it is. So I'm going to go to 192.16, oops, numlock would help. 192.168.56.191. Okay, and because I have a temporary web server running on that machine in the malware folder, that becomes what we call the document root. I can right-click on that, and I can save the link as. Now, you should have a folder called Kali Malware in your home directory. That's what I have here. And you want to save this in that directory. Now, I've already downloaded it, so I'm going to replace what I've just created. So that now, when I take a look at my folders, here we go. I have the malware created today. Sorry about that Teams alert. Okay, so I have the malware that we just created today. Perfect. Now that I have this done, there's two different ways of managing how to take a look at what we're going to do with regards to this this executable. First tool we're going to use is hex dump, and it's pretty straightforward and easy to use. I will make my screen full size, my terminal full size. I will zoom in a little bit so you can see what I'm doing. Doesn't seem to be an option with REMnux here, but that font should be fine. So I'm going to use hex dump, and I'm going to do it against malware adduser. And what this does is it allows us to take a look at the contents of the malware adduser file. Should type in the file name correctly, malware adduser.exe. As you can see, all we're really getting is hexadecimal information that's not really all that clear to us. So what we will do is we will say, hey, you know what? Give it to us in some ASCII characters that we can understand, like that. And when we do that, now we can see some of the ASCII characters. Unfortunately, it scrolls off. It's kind of difficult to see. Now, if you've done what I've asked you to do in the past, you've gone into the preferences and you've added an extra 0. You set it from 1,000 rows to 10,000 rows so that you can scroll up in your terminal window and see what's going on. Now, this can be tedious, but we're looking for suspicious content. And when we scroll through, we actually find command.exe command. And what this command is trying to do is add somebody to the system with the username malware adduser with the password user@123. So right there is our payload inside of our executable. Now this isn't the most elegant of solutions, I have to admit. This hex dump really doesn't give us what we're looking for. So I'm going to recommend we're going to use vbindiff, and with vbindiff we're going to use the malware adduser.exe again, but this time you can scroll down. You can hit the space bar, move down one screen at a time. I'm just hitting the space bar, and again I'm looking for clues. Oops, almost scrolled past it. Now I'm using the up arrow cursor key on my keyboard. And when I do that, again, I find the command.exe, and it's a little bit more legible, and it's a little bit more elegant a tool, I find, rather than using hex dump. Hex dump will work. vbindiff, I think, works a little bit better. When it comes to starting the competency on this, I want you to use vbindiff. I would like you to also add this as a screen capture into your reports. We have reports available to us in Learn. We've covered the reports for malware analysis. The target audience for these reports is not both technical and non-technical. You're not writing these malware analysis reports to hand off to the head of HR or anything like that. These are reports that are to be used by the SOC or the SIEM team as a way of responding to an incident that is happening and is ongoing. Very technical audience, and they will understand the different parts of the report. So we don't have to make it as easy to understand by a wide target as we had to with our malware and with our pen testing reports that we did last semester. So at this point, start filling in as much as you can on the report. Include a screen cap demonstrating exactly what you found when you took a look at the executable, specifically the command.exe. I should mention, this is the one and only time we are going to use either hex dump or, more preferably, vbindiff in this class. Okay? We're not going to use it going forward. We just used it this one time to analyze this relatively simple but very real malware. As always, if you have any questions, reach out to your instructor. Good luck.